What if I tell you you can build your own AI-powered air quality monitor station that you can ask questions like, how is the VOC index affecting my house right now? No code, no cloud, and everything fits in your pocket. So here at Premier, we work in a very cool location called Founders Inc. Garage. So here at the garage, I have knowledge. I have a resin printer right behind me, and I have an FDM printers right here. When you flip the camera, also have a soldering station. Many other startups work right here. It's a paradise for makers and a nightmare for air qualities. Indoor air quality impacts us more than we notice. Study shows cognitive score dip when CO2 level creeps about 1000 parts per million, about 15% hit to a complex task performance. Study shows VOC, which stands for volatile organic compound, such as alcohol, any organic vapors, can trigger headache or even migraine. And as you can see, the printers right behind me, especially the resin printer, can emit a lot of VOCs. And soldering station and other startup using angle grinders can cause a lot of PM2.5 fine particulate stuck in your lawn and causing asthma attack. So let's monitor the three main villains, VOCs, CO2, and PM2.5, and translate their cryptic units into plain English. Before we dive into this project, let's just take a look what's available on Amazon. So this one, Amazon branded air quality sensors, a keep tab of PM2.5, VOCs, and carbon monoxide. It doesn't have CO2 levels. We want to measure CO2 level mostly because it actually impacts your performance. And this device checks two of the three boxes we want. So this one has CO2, temperature, humidity. It doesn't have PM2.5. It does have e-ink, so pretty nice, but it doesn't basically fall short 2 out of 3. So it doesn't have VOC, it doesn't have particulate, only CO2, temperature, humidity. Yeah, this one seems to have a lot. The TVOC, CO2, PM2.5. Again, doesn't really answer the contextual question like what's the health impact, right? They only tell us whether it's healthy or not. Alright, so after that quick Amazon shopping, we noticed that not all the air quality sensors are the same, right? Some check one of the 3 boxes, some check all the 3 boxes, but measure the total VOC. We want more information out of that. We want to know what kind of VOC exists in the air. For those sensors that check all 3 boxes, the problem is it doesn't really provide contextual answers based on the readings. I want to know what does 2000 part volume actually negative impact on my performance or on my health. I want to ask actual questions. So let's actually build intelligent air quality sensors that can provide me contextual answers and with actual intelligence with actionable insight. To be able to provide contextual answers on these air quality readings, at the heart of this project is an AI agent that be able to read these readings and have the knowledge of air quality in relationship with the human health. And that's why today we're going to build with Distiller Alpha Dev-Kit. This is essentially an AI workstation that is, the size of a credit card and has full hardware access to all these sensors. The nice thing about it, you don't have to code anything. And just follow along today and you can create your own. All right, let's go to Adafruit and shop some sensors. Alright, through the magic of video editing, we have the sensors right here with me. This is the VOC sensors. We have the CO2 sensors right here. And we also have the PM2.5 particulate sensor with me. Grab our distiller, connect the power supply, and let's SSH into the device. If you don't know how to connect cursor to our device, we have a separate video linked down below. In the cursor interface, let's copy the relative path of the MCP server directory and copy it into our new chat. And we also drag our lm.txt, which is a file that contains all the information AI need to know about our hardware and the software stack. Now, telling the AI agent we need to create an MCP server that get the VOC index of the air. For context, you need to know what kind of sensor we connected to it. So I just copy paste the Adafruit tutorial right in the chat window. Cursor has the ability to search internet on its own And while we wait it to finish generating the code, we can go ahead and grab our sensor and connect to it. From the cursor chat window, we can see the list of available tools for AI to call. And we also see that there is a requirement we have to install the Adafruit CircuitPython SGP40. On the distiller, all the packages are stored in a virtual environment. Let's first activate the virtual environments. Now type uv pip install and the package we just copied from the chat window. Let's double check what cursor have created, and all we need to do next is to restart the distiller and we should be able to test it. Alright, let's try. Hey, can you tell me my VOC value right now? Everything you see here, including the local AI, the UI, and the MCP architecture, come with the distiller. The tool we just created are an MCP tool for the AI to check the sensor data. Now we can see the AI is trying to access the tool we just created. Executing tool checks sensor status. Now it's calling another tool to get actual values. From the earlier cursor chat, it reminded us this raw VOC value need compensation from temperature and humidity. And we can see our agent is also reminding us of this. And nice that we actually have another sensors for the CO2 that has the temperature and humidity. So let's connect the sensors with the CO2 temperature and humidity. Because it's I2C, we can actually daisy chain them together. Now going back to cursor, there are two things I want to prompt. First is to add this new sensor capability. Second is actually to add the temperature and humidity compensation for the VOC. And for a little bonus, we can just change the name for this SGP40 VOC server into air quality server in general. Let's generate. Because we add a new sensor that requires a separate Python package, let's re-enable the virtual environment and install the new package. Hey, can you tell me my temperature, humidity, CO2 level, and compensated VOC level? That's great. Is this safe for human? From the answer provided by the AI, we can see that it cannot provide the answer that we're looking for because it doesn't have the contextual understanding of how the value are correlated with the human health. So the next step we need to do is to go to ChatGPT, deep research to dig out some scientific data on the correlation between the health data and the raw readings. Here, I dragged my air quality server Python file and tell ChatGPT I need to have an LLM system prompt. The goal of this prompt is to provide contextual understanding for these raw air quality data. Here, ChatGPT is just asking us for a few questions before you can start deep research. You can answer them based on your preference. Great, now ChatGPT is doing deep research and lets us connect the last sensor, the PM2.5 sensors, to our distiller board. And we will repeat the same process of adding the MCP server using cursor. After ChatGPT have finished deep researching, let's take a look of what it generates. Here, I also asked ChatGPT to convert it into a format where we can just copy-paste into the system prompt. Now, let's paste the default system prompt into the default config JSON at the util folders. While I was scanning the deep research result, I realized that the VOC is represented as a VOC index. Therefore, we have to convert our raw VOC value into VOC index. Let's just take a look at what that means. Let's just Google the SGP40 sensor datasheet and take a look what the VOC index really is. From the datasheet, we can see that the raw data need to be converted using an algorithm, and let's just Google for the algorithm. Looks like we have found our GitHub repo containing the algorithm, and it's provided by the sensor company. Let's just go ahead and click the index algorithm and try to copy paste the C file, and we will let the cursor to convert this algorithm from C into Python. Here I speed up my process by 10 times, so not to bore you. Essentially, we're just converting that C algorithm into Python, and also like cursor aware that we're in an MCP server environment, so we dragged lm.txt as well. Here, cursor not only will convert it into a Python algorithm, but also I'll update the MCP tool list, so now our AI can just get the VOC index directly. Now, after applying our new changes, let's restart the distiller and test it out. How does the CO2 level in my air impact my brain performance? Now the AI says the level below 1000 is good, and level 1000 to 2000 is considered reduced performance up to 30%, and level above 2000 are too high. Now let's take a look at what it says about our current conditions. Our current level is about 1201, and it moderately affects my cognitive function, so I should open my windows. Now let's check the PM 2.5. Hey Distiller, I feel like my air has a lot of airborne particulates. Can you check? Now the AI says we have about 5 microgram per cubic meters of PM 2.5 and 4 microgram per cubic meter of PM 1.0 and 8 microgram per cubic meter of PM 10. And AI says overall it's within safe ranges, so no worries. Now let's check the VOCs. Hey Distiller, how is the VOC index affecting my house right now? Now Distiller says our VOC index is 100 out of 500s, and let's take a look at what that actually means. Alright, 100 is considered as moderate, and sensitive individual could experience mild symptoms with prolonged exposure. So we should consider remove any odor source using air purifier. For a good comparison, I have traveled to this campsite near California to test the air quality outdoors. Here's a beautiful location near Russian River, California. I have bring my distiller with me. How is my air quality right now? The air temperature is comfortably warm, about 21 Celsius, and the humidity is about 58.9%, which is not too humid. It's very pleasant right now. CO2 concentration about 524 is really good compared to what we have indoors, which is about 1200s. And at this demo, I forgot to add the VOC index, so it's showing the VOC at the wrong value, but it does actually tell us it's really bad for us. And fine particulates all 0, it's really good. Alright, as you can see, there's still small improvement we can make, such as on the VOC index algorithm, or we can add more context that is specifically to your house. Maybe you have asthma attack where you care more about PM 2.5, or you have migraine where you care more about the VOCs, or the particular VOC that you cared about. You can still customize everything. So to wrap it up, today we have built an AI air quality station with contextual understanding from scratch. And we have no code, everything done by cursor, and it's handled by a local AI. If you want to grab a Distiller Dev-Kit, click the link down below and let me know what you want to build next.